Mining community, welcome back to another episode of the Dig Deep the Mining podcast. And today we have a returning guest who first appeared back in April 2019, which was episode 22. Michele Ash, who's about to join Oz Minerals in a newly created role as a technology executive, which will involve work around digital, robotics, automation, mining technology, and transformation. So Michele's on the podcast today to talk about obviously this new move, but also how using robotic mining, using small swarm robots to mine or blockchain to drive exploration investment, because obviously that's her specialisation, and I think our audience will be interested in what you've got to say. So that's welcome, Michele, to the podcast. How you doing, Michele?
I'm fantastic. Thank you for inviting me. I'm really looking forward to speaking with everyone.
Yeah, and I appreciate your time. And yeah, at the time of this recording, it is Australia Day, so I appreciate you taking the time up on that public holiday. So I wondered if you can give us just a brief background of yourself. Obviously, if people want to know a little bit more about you, they probably can visit the episode that we did back in April 2019, where you probably gave us a little bit more overview of your background. But I just wondered if you can tell us a little bit about yourself, and obviously your new move to Oz Minerals, which you're going to be starting in March. Yeah, so I hand it over to you.
Yeah, thanks, Rob. It's fantastic to be here, and I'm really looking forward to some of the questions and speaking to everybody in the podcast. So yeah, look, a little bit of my background, on the fact that I can't believe it was 2019 when we spoke last. That certainly has gone by fast. So look, my background, I've been in mining for about 30 years. I started in mining in 1992. Originally, I was a civil engineer, but have worked my entire career in mining as a mining engineer. Other than actually a couple of forays, I spent 3 years in pulp and paper in business improvement, and I spent 5 years as general manager operations for a petrochemical plant. So a lot of these skills that we learn in mining around leadership and understanding problem solving are highly transferable into manufacturing. But my mining career, I've been in both operational roles. So, for example, I was blasting engineer, I was superintendent of a truck shop, I've run processing plants. I was the general manager of Yandy. They called it project manager because it was a contract operation at the time. I was general manager of Bullion Hulu. I was chief operating officer for Acacia. And then also a number of strategic roles. So general manager of strategy for Chinaman Metals. I was head of asset planning for BMA, as well as the company secretary. I was chief innovation officer with Barrick. And then my current role, so I've been moving, sorry, before I say that, I've been moving between operational and strategic roles, which I really enjoy. You know, I enjoy working with people, working with teams, and that operational delivery. And then, you know, I really enjoy the option and ability to think strategically as well. And then my last role actually was outside of mining as CEO of Geolvia in a software company, Dassault Systems. You know, mining is our biggest client, so certainly, you know, a lot of focus in mining, but also gave me an opportunity to understand some other industries such as construction, infrastructure, chemicals, energy, etc. So that was a very exciting opportunity and fantastic team at Dassault, and especially the Geolvia team, and some great software that we developed and still developing. And then, you know, as you say, my next role, I start with Oz Minerals in March, and for Oz, I'll be their technology executive, so accountable for technology transformation and really helping Oz team achieve some of the things that they want to achieve, which I think is very exciting, because at a very fundamental level, they want to rethink mining. They want to achieve some of their sustainability goals, the reduced OPEX, CAPEX, that can be achieved by solving problems using technology, and obviously really that means people solving those problems and then changing the way that they think about mining or go about doing things. And so I think a very exciting team, as well as a very exciting opportunity to help transform not only Oz Minerals, but in so doing help transform the industry. But as I think I said last time, I'm exceptionally passionate about it. I love mining, because mining touches every person on the planet every day, whether it's in cleaning our teeth, putting out our clothes, riding our bikes to work, driving our cars. But because it touches everybody every day, it's behest on us to fundamentally change even faster our sustainability, our footprint, and grow our handprint, so that we set the way, and so that people, whether it's 8 million, whether it's billion, or whether it's 10 billion, but the people on the planet can increase their standard of living, but not destroy the planet in doing so. So that's what I'm passionate about, and very excited to be part of that.
Yeah, and you can obviously certainly hear your passion in that description that you've just given. So what made you join Oz Minerals?
Yeah, so look, I think, it was a very, very hard decision, because Dassault is a fantastic company, great team with Geovia. We're building some amazing products and capabilities that will help transform the mining industry. But I think two things with Oz. I think Andrew Cole is a fantastic CEO, and I was exceptionally impressed with his vision around mining, and what he wants to achieve, or what he'd like to help the Oz team achieve, in terms of being a very different mining company, driving fundamentally different sustainability outcomes, and rethinking the way that they go about doing things, and therefore influencing the mining industry to do so. And similarly, when I met the executive team, as well as a number of the board members, I really felt that this is the team that will be able to achieve a lot of those things that many of us just talk about. So I'm very excited to be part of that journey with the Oz Minerals team.
Yeah, no, that's good. That's good to hear. And so, what are some of the problems that the use of robots in mining are sort of trying to solve? Obviously, there's probably numerous problems out there that robots could be of benefit, but I suppose what are the main problems or challenges where a robot will significantly make a difference?
Yeah, no, look, absolutely. So if I just step back just for 5 seconds, I think there are 5 broad problems that the mining industry is trying to solve at the moment that will radically change the outcomes for the industry, for the communities, for our stakeholders, our shareholders, etc., our future workforce. And they are ore body knowledge, global ore body knowledge. So if we could know our ore bodies and potential ore bodies down to the last gram, to the last metre, we could find them 20 times as fast at half the cost. So that's a big challenge for us, but we need to be able to do that if we're going to help the world decarbonise, because for example, there is just not enough copper to decarbonise the world, so we need to find more rapidly. Second is to automate and to electrify our mines, not only so that we can use renewable energy, we can use less carbon intensive energy, but also automate so that we can not only have people working in significantly safer and healthier environments. I mean, I think even with the safest mines, and mine safety has improved radically in the 30 years that I've been in the industry, but even the safest of the mines, I think everyone has to agree that we are safer still from a health outcome perspective working in offices. So how do we get people and all of our people into office style environments and have literally at the coalface robotic technologies. The second part of automation, though, is really helping people solve problems faster, more completely, and give them insights that we just don't have at the moment. And so, the use of AI to give people insights to solve problems fast, to allow people to be more creative with the way that they solve problems. I think that is part of that whole automation conundrum as well. And in so doing, again, we will radically change the safety outcomes, the health outcomes, the operating and capital costs because of this much more creative problem solving, more collaborative problem solving. The third is around precision extraction. And so how do we, in an ideal world, just extract the atoms that we are interested in, the metal atoms? But, more broadly, how do we take just the mineral that we're interested in and stop moving so much waste? And again, if we think about the sorts of ratios that we have, gold, it's around about 11 tonnes of waste to 5 grams of ore. Copper, it's around about 9 tonnes of waste to around about sort of, depends what we think the ratios are, but around about 4 kilos of copper. And so if we could stop moving all of that waste, again, it would radically change sustainability outcomes, because all of the energy, the fuel, the waste dumps, the tailings dams radically change the health and safety outcomes, as well as OPEX and CAPEX. The fourth one is really around how do we create more symbiotic relationships with our communities and distribute wealth in a different way. And especially as some of these technologies change jobs, change the face of mining, the structure of mining, how do we think about driving value for communities and for governments? And then the fifth one, is really around how do we rethink business models in order to drive some of these better outcomes and shift our thinking. And so if I look at all those 5 problems that we have to solve, come back to robots and robotics, I think the key area for automation and for robots is those things that have a high degree, where I'd be pointing them straight away, is those activities that have a high degree of health and safety risk associated with them. So, for example, I think there's some great examples at the moment of an organisation that has developed a barring bot. So barring, for those that don't know, is basically knocking the loose rocks off the walls and the roof of tunnels underground with a big long metal stick. And you can imagine that's it has some risk associated with it, that the person will get hit by the rock. So sorts of jobs like that. There's another company that has developed a robot that ties in blasts, again, to remove people from that activity. There's another robot that's been developed to do some of the belly plate changing, which again, is a something that has created a significant injury historically in mining. So I think there's a whole raft of those sorts of solutions that are absolutely right for robotics. The second group, which is sort of related to that, is there are still some tasks that we do in mining that again have significant risk associated with them. So air leg mining, or even sometimes face charging, face drilling. Can we get robotics to do that? And whether that robotics be an automated machine or drill, or whether that be something that is more discrete and smaller, a robot, for example. And again, there's some great examples of trying to develop a swarm of robots. So robots that have different functions, but also work together collectively to instead of having people using air legs for some of that narrow vein mining, that the robots go in and they slice the vein, they take that material to some sort of ore pass or ore collection point. They move the rest of the material to waste. They continue cutting, etc. And I think not only reducing health and safety risk, but also in that particular case, you can now start making some of those those ore extraction points smaller, because you're not needing to get a whole person necessarily into that area. So can we be, again, more precise with the way that we extract that material? And the other advantages of things like the robot with using a cutting tool can you don't get overblast. They can much more precisely remove the piece of material that you're looking for. So so I think there is another really good example of the sorts of things that robots can do. There's another category of things where it might be a highly repetitive activity, where again, robots or automated technology can do the same thing in exactly the same way, and drive better outcomes, either safer outcomes. And we've seen this in with use of autonomous trucks, where when using autonomous trucks, because they follow exactly the same path every time, there's now a whole question around, can we reduce the size of ramps and the multiples of ramps? Because as you know, we normally use 2.4, so 2.4 times the size of your widest truck as the ramp width. Some companies use maybe even slightly higher than that. And that 0.4 is basically to take into account safety, error margins, etc. And so, as I said, sometimes some companies use 0.8. Can you get that down to 2.1 with autonomous trucks? And then what does that mean in terms of the reduction in the amount of waste that we move? The reduction in first the size of the ramps, and then second, the reduction in the amount of waste that we move over the lifetime of that mine. And again, a similar thing would apply for other uses. There's also examples, obviously, in warehouses, where again, you might be better off having a 24-hour capability, but at a lower rate, to process and to put things onto shelves, to take things off, to send them to different parts of the mine site, for example. So there's some very interesting trials in terms of what's the accuracy and the efficacy of using robots in order to manage a warehouse, to distribute goods. Can you get them to distribute them all the way down to, say, a driller underground? If you have a series of autonomous or robotic equipment, does that then fundamentally change the way you can think about the mine design, etc.? So look, I think there's a lot of really interesting examples and problems that people are trying to solve using either robots or autonomous technology of some kind. And as I said, they all start touching on one or more of those key 5 system level innovations that I think as an industry we should be trying to solve.
Yes, certainly there's a compelling argument to use, obviously, robots and automation in our industry. What are probably some of the other challenges, some of the other fundamental challenges that still need to be resolved and possibly may not be obvious? Just wondering if you have any thoughts around that.
Yeah, so look, I mean, I think there's still a number of challenges, and there's some trials going on at the moment, both in an underground environments and open cut environments, to make sure that the the robotic technologies are robust enough in some of these environments that we find ourselves in mining, which can be highly acidic, they can be wet, they can be GPS denied, they can be obviously dark, so having to navigate with particular sensors, etc. And in fact, in some of these cases, robotic technologies, with the sorts of sensors we can put on them, with the sorts of metals and materials that we can use, are actually showing that they can stand up to these sorts of treatments. And it's really interesting. Well, I found it very interesting working with some of the robotic companies around how they think about those sorts of problems and that sort of problem solving. And a lot of them, interestingly enough, are also starting to think about how they might put robotic technologies on the moon, on Mars, so in outer space. And so what's interesting is to watch them think about, how do you reduce maintenance? What happens if something does go wrong? How do you extract that robot? How does it how do you keep it as robust as possible? So I think a number of those problems that they're working through, and in fact then set them up for success if they do take these technologies off the Earth's surface and into space of some kind, because even with the remote challenges that we have in mining, and even with the very challenging environments that we find ourselves in, of as I said, humidity, acidity, etc. It's still immeasurably easier to pull a robot out of a even 2,000 kilometre down mine, 2,000 metre down mine, than it is from the moon or to Mars. So certainly one of the groups of problems is around, or challenges, is around the environment, and making sure they're robust for the environment. The second group of challenges is really around, they can only really be used when you have communications in the mine. And so, as mines, communications becomes it should always have been a backbone of our industry. But many of us have worked in mines where you might have to walk 200 meters to even get radio reception, let alone having 4G or it's high speed data communications in the mine. And so that is one of the challenges, is how do we upgrade the communication systems? How do we make sure that not only the robots but people are able to use data to send and receive information, data, etc. In our mines? That one I think is pretty much solved. It's really a matter though of mining companies embracing some of that technology. And then I think there is also then a raft of challenges that are around, how do the robots interact with people? So if you are going to have, which initially all of us are going to have anyway, is a environment where you're using robots as well as people, maybe even sharing environments. And again, we're working through this with automated equipment, which is just a form of robotic equipment. How do we make sure that people are safe, that the robots or the autonomous equipment will make the appropriate decisions, will stop when a person might be coming within their line of movement, or when they have a major fault, will shut down and then seek help. And I think so. There's a whole raft of, how do we have habited areas, so how do people and robots work together? And interestingly, we can, I think, look to manufacturing industry, where manufacturing has been integrating people's activities and robotic activities for some time, maybe not in a highly mobile way. So I think that's an additional challenge for mining that we need to think about. And then there's those raft of challenges around what does it mean for people who are doing the roles that now are going to be done by robots. So, if we go back to the example of the barring bot, so the person who does the barring, there's two conundrums there. Is one, how do they now interact with this barring bot? Let's just say they're a driller that's going to come in next and do some drilling. So how do we work through that system of work so it's efficient and effective? But then, let's just say that there was somebody their whole job was barring, as their whole job is driving trucks, etc. Now there are no truck driving jobs because we've automated that. What does that mean for those individuals? And for me here, there's a lot of pivoting of roles. So whilst I know there's this constant debate around, will use of autonomous equipment or robots, will it lead to more jobs? Will it lead to less jobs? I personally ultimately believe it will lead to more jobs because it will help grow GDP. It will help mines become more productive, which means and efficient and effective, safer, which means we will have more mines, more ore will become economic, etc. We'll have more materials. So, ultimately, in my mind, it leads to more jobs. But they are different jobs, so we no longer have truck drivers, for example, but now we have more people that need to maintain robots, more people that need to manufacture the robots, more people that need to train the robots, more people that need to monitor what those robots are doing or what that autonomous equipment is doing, and then optimize that and do that creative thinking. As I said, there becomes more mines, more ore, etc. So, ultimately leading to more jobs. But the jobs are different. And so, I think at a very fundamental level, we need to start pivoting our thinking as an industry, as individuals who work in the industry, as well as even, back into the education system around what are the sorts of skills that we're going to need into the future, and whether that future is next week or whether that future is in 10 years' time. And how do we start pivoting towards that? How do we start retraining people? How do we start upskilling people? How do we start in schools generating, more people with, STEM capabilities, let's say, because, a lot of the world that I'm describing, there's still an underlying, at least base of STEM, even if we're not all going to be masters and PhDs by any stretch of the imagination. But, some basics in science and basics in computer science, etc., become, I think, more important, even down to some of the practical trades, etc. As we electrify and automate and have, more robots, we'll have more HV work, for example. We'll most probably have more welding work. So those high-end welders, HV operators, let's start training people into those roles, because some of those are, a challenge to get hold of even now, let alone, when some of these technologies become, significantly more available within our industry or utilised within our industry.
Yeah, I've just made a note around obviously upskilling staff. Where will they get this training? Are you seeing companies or even institutions start to implement certain trainings or courses ready for this new transition into this new technology world? I mean, for instance, if there is some truck drivers listening to this podcast, what could they be doing now to move their careers forward if their career as a truck driver is going to be ending? What could they be doing now to possibly move forward and transition to this new technology type of environment?
I think there's actually been a lot, and when I say things, at the governmental level, at the university level and at the TAFE level in the last sort of 5 years, where really the last 2 or 3 years, most importantly, there's been a lot more emphasis put, in universities and TAFEs. So, universities, if you want to do some sort of bachelor's or master's or those sorts of things in some of these, whether it be robotics or computer science or, mechatronics or, electrical, electronic, etc. But also at the TAFE level, for those of us that are more practical and tangible and, want to get more into how do you actually build or maintain some of these robots? How do you, there is a number of courses now available for people to get access to, both physically, so at local TAFEs, at local universities, of course, COVID restrictions willing, but also now what's really exciting is virtually. So you can go online now and do a number of courses in preliminary technology topics, absolutely free of charge. You can learn a lot about it. The only time some of the online courses actually charge you is if you want the formal certification to say that you have passed that course. Now, of course, there's some advantages in doing that potentially, but there's a wealth of information and a wealth of education that people can have online, both in terms of some of those tangible practical things, how to build, how to maintain, how to train some of these things, as well as some of the more esoteric, so about coding, about as I said, some of the engineering disciplines, etc. So I think there's a lot that people can do right now to take that matters into their own hands as such, and build their own skill base and their own capabilities. On top of that, I think mining companies more and more are realizing that having people with the mining background, so whether that background is truck driving or drilling or blasting engineering or mine engineering or geology, whatever the background is, and that practical experience, having that as well as some of the capabilities in these technologies, having those two things is really valuable. So there are a lot of mining companies that are offering to their employees courses or the opportunity to take courses both within the mining company framework as well as outside, to again upskill and to grow. For example, Barrick worked with the Elco community TAFE to create again a number of programs for their employees, so that they could start some of this sort of training. Some do it in-house. I know a number of mining companies now have started doing in-house training for things like Python, for example, which is a programming language for people that are interested. So I think there's a wealth of things outside the company, inside the companies, and I think more and more, mining companies are also, whether it be through minerals councils, whether it be through other bodies and institutions, or even just their own collaboration coming together, also starting to influence, and some of that is evidenced by the courses and the change in the courses, but influencing TAFEs, universities, sometimes even the setup of more independent training providers. And I think now starting to focus in on schools, and to really help us all think about the sorts of curriculum maybe that and I know a number of governments are very interested in this as well. Like the Canadian government, for example, it's recently done a review of their school curriculums and the sorts of things that should be included in school curriculums. I believe the Australian government is either just done or about to do, or it's a state by state thing in Australia, but a couple of states have done a similar thing. so I think there's that, and then the other thing that's been really interesting. So there are now sometimes in some countries anyway, some private not-for-profits that are really targeting specific skills, and in some cases in specific groups that are disadvantaged, and so sometimes that can be First Nations or Indigenous groups, sometimes it can be girls or women, other times it can be all sorts of different groups, but I know of one that I was a part of called Hacker Girls, and that particular not-for-profit, what they had recognised is that something like 97% of the computer science coding graduates were men, and so they wanted to try to help reshift that imbalance for two reasons. One, it meant that most software-related technology businesses, especially startups, were headed by men, and they felt that it would be helpful to have more women and just different perspectives in those sorts of career choices. And then secondly, that a lot of the software in the gaming side of things anyway is actually bought by women and used by women, but yet developed by men. And so, again, maybe that industry could help with some diversity, or could be helped by having diversity. And so what their whole thing was targeting girls between the age of 8 and 12, and developing their coding skills and getting them involved in hackathons and that whole mentoring process to do that, to again try to influence young girls to not only not think but know that computer science or coding is something that could potentially be in their future, but also just give them some confidence that they can make those sort of career choices should they wish to. But yeah, so there's I think there's lots of things available, both for your families, people who are listening, for yourselves, or for mates that that might be wanting to develop their skill sets. And that applies to all of us. I've had to upgrade my skill sets. I certainly didn't know anything about computer science. So yeah, I had to upgrade my skills because 5 or 6 or 7 years ago, I didn't know anything about artificial intelligence, blockchain, robotics, any of these technologies. So I had to go back and not only read some books, but do some courses online, speak to a lot of people, so I think all of us are going to need to upgrade our skills, no matter what your background it has been.
Yeah, certainly, and that's good to hear, being obviously myself in the recruitment and career space. So I mean, everyone in whatever industry you're in and whatever level of role that you're doing or playing, you always need to add additional skills and improve your skills. But I suppose this is just slightly different with this new technology, in that the skills that we learn are pretty new to the globe. Globe, really. So, but it's just making that transition.
Exactly.
How quickly is the industry adapting to all these new advances in technology as a whole, whether it's robots, whether it's AI, and what reservations may they have?
Yeah, so it is fast. And innovation officer for Barrick. In fact, it might have been 7 years ago now. And at that time, I know I used to make a joke that the mining industry was one of the least digitized industries, and in fact, toilet cleaning services was more digitized than mining, which in fact it was at the time. And I think now that can't be said. I think mining really has started embracing digital technologies and digitizing. So digitizing is really taking some of the processes that we used to do in on paper, and literally putting them onto computers. So, rather than having maintenance forms now, we might fill in something on an iPad as we do that maintenance activity. So it's immediately digitized. Or, in geology, we used to have core sitting in a core yard, and somebody would come and, draw on a piece of paper and log it, etc. Now we scan it straight away, and so we have it in a digital format, both in terms of pictorial as well as in two-dimensional sort of graphic format. And now we're starting to see autonomous equipment becoming more common. Still not the average mine, but more common. Robotic equipment, I think, is at very early stage. Blockchain technologies at a very early stage. But I think, there's three big things for us to think about as an industry. One is, what are those key problems that we're trying to solve? Because I think the risk with our industry, and I see it a little bit already, is that we're grabbing technology and then finding a problem to solve with it. And that can be a really costly way of going about it, rather than saying, what's the major problem that I want to solve that's going to give us a huge value uplift or a huge safety improvement, etc. And then let me find the right technology to solve that problem for us, to help us solve that problem. And so I think flipping from focusing on technology to focusing on the problem will be really important for the speed at which we will uptake going forward. I think secondly, focusing as a mining company on the implementation of that technology and getting our people to use that technology to solve that problem, to change their behaviour, to do things differently, and maybe even think about how we fundamentally do things differently. So, rather than just replacing a diesel truck with an electric truck, why don't we think about whether we need a truck at all? And how do we convey material, which is what we're really trying to do, and then what's the best way to convey material, from wherever you want to go to wherever it needs to be, to meet the targets that we've got. So reduced carbon, reduced OPEX, reduced CAPEX, etc. How do we solve that problem? And then, once we've solved that problem, how do we get people to do things differently? And so I think if mining companies really focus on how do we get people to implement this technology efficiently, effectively, fast, change the way they do things as fast as possible, and then, get the partner with technology companies, and get them working on the technology and optimize and improve the technology. I think that's a really good way to think about the different roles. I think the third challenge that we have is, one of the things I do see at the moment is, even when organisations are using these technologies and they've got a number of examples within their organisation, they're struggling to connect all of those problems together and all of those examples together and to solve a system level problem, rather than just a point solution problem or using just a series of proof of concepts. So I think, thinking about these system level changes, system level problems, system level innovations is going to be important to, again, moving forward. And then I think the last one is really rethinking how we think about risk. So I think one of the things that is slowing mining companies down from solving these problems in a different way with technology is the perception of risk. And I think we often, as an industry, we assign zero risk to the way we are currently doing things because we understand it, we know it, therefore it can't be risky. And we apply risk to those things that we want to do that is different. And I think that is both erroneous. So, for example, buying diesel trucks today, I think none of us can think that can have zero risk, especially with the amount that investors, communities, our workforce, the public at large is demanding a reduction in carbon as being, part of our industry, part of all of our sort of thinking. So, I think it can't be that it has zero risk, A. But then, I think it's also thinking around, not only what is the risk of this new technology, so if we're talking about battery electric vehicles, just to give the flip side of that, what are the real risks, and not to elevate those just because we haven't necessarily had personal experience. And then, I think one of the ways to reduce risk is to use virtual twins and virtual twin experiences even more. And so what I mean by virtual twin is not a two-dimensional, replica of what happens in a mine, let's say, but actually developing a four-dimensional, so three-dimensional and time simulation that people can run and experience and understand around how is that change going to change my mind? How is it going to change the way we go about doing things? How is it going to change some of the metrics? What does that look like over time? Not only so that us technical people can understand and we can run simulations and multiple options and make ourselves feel comfortable that this will work under different operational scenarios and be much more confident, but also so that we can communicate effectively that to boards, to governments, to communities, to those people who are not technically as capable as we might be. And I think, that will speed up the rate of innovation in mining, the rate of acceptance of these digital technologies. If we can really focus on those four things, and especially on the virtual twin experiences.
Yeah, I've got two more questions. So what else do you see mining companies needing to do to help them transition into this new or more advanced technology world or new era?
Yeah.
And I suppose focus on sort of medium and smaller companies. Obviously, larger companies have more investment, more resources to implement changes quicker. But for the smaller and medium type organisations, what do you see them needing to do?
Yeah, so for the smaller and medium-sized organisations, in fact, I think the medium ones are the ones that are in the prime seats. The big ones sometimes can have the cash, have the will, but it's like turning the Titanic. Whereas the small ones sometimes don't have enough resources to be able to even devote attention sometimes, let alone capital investment into some of these technologies. And it's the medium-sized companies that have sort of both. They have at least some capability to invest, and their ability to pivot can often be, significantly faster. So I think from a medium-sized mining company perspective, focusing on what are those things that are going to drive the most value, those problems, what are the high-value problems, and then looking to use technologies that aren't necessarily new to the world. Let some of the bigger mining companies sort of work on some of those new to the world technologies, and try to sort through making those technologies more robust or making them more applicable for mining, etc. For the medium-sized companies, I would use a lot of the technologies that are already available, but are new and interesting and novel ways to solve problems that you've got. Maybe even, technologies that are available in other industries, where your contribution to bringing these technologies on is to make them more applicable for mining. So at least you don't have the technology risk. It's really around how do you make this applicable for mining. So high value problems that you're solving, and then solve them with technologies that aren't new to the world, but you might have to make them new to mining. Do it in a collaborative way. So again, the more mining companies that can, focus on this problem because it's high value, work with these particular suppliers to get the technology right, etc., the cheaper that technology is, because you've just got a greater pool of companies and that are contributing to its development. You've got a greater pool of companies that are then purchasing that particular solution. And so the price of that solution comes down. As we've seen with with solar, for example, solar 10 years ago was significantly expensive, more expensive than it is now. In fact, it's another zero on the, not a couple of zeros on the end of the cost. For smaller mining companies, again, it's similar advice. But also, I think for the smaller mining companies, especially if you are pre-mining, so you're now in project phase, I would really be thinking hard about how you make some of these technologies work for your operations, because I think it really will set your. So again, it's not going to cost you a lot to be more cerebral about the solution set, to come up with with different ways of going about doing things, because I think it will set your operation up for higher value and more success going forward, both in terms of bringing your op cost down, but also potentially higher purchase price. At the time of as most small mining companies ultimately become bought by medium-sized or larger mining companies. If you've got a fully electric mine, at some point in the future, that's going to be a lot more valuable than a fully diesel mine, for example. So I think different problems, but focus on the high value problems. Focus on technologies that are already available. With the smaller ones, I'd focus on technologies that are not only already available but have been tried in mining. Maybe by some of those medium-sized mining companies, or maybe the bigger mining companies. And implement some of those, and leave the bigger mining companies to be more experimental, maybe with very new to the world technologies.
Yeah, that's great advice. And lastly, what are the next key steps and future outlook for using robots in mining?
Yeah, so look, I think again, a lot of it is what we've spoken about. So I think it's making the robots more robust. Though I think the ones that I've seen in trial are actually they've been I think sensational in dealing with acidic environments, with rocky environments, with humid environments, with high temperature environments, etc. The second is really getting more mining companies to understand the capability of those robots and work together, because again, at the moment, the robots that I've seen in production, they're not as expensive as they used to be. I mean, it used to be $2 million a robot, back about 10 years ago. They're now sitting, in the hundreds of thousands, but that's still pretty expensive. But again, because at the moment there's still not the supply draw. But I think once mining companies come together and they see the capability of these robots, and then look to solve those same problems in their own mines, then of course that will drive the cost of these robotic technologies down. So I think there's some challenges. There's the challenge of retraining your workforce. Absolutely. There's the challenge of even working with governments, because again, one of the companies, robotic companies that I know of, they've been working with the local government to try to build some of those robots, close to where those robots are going to be used. So actually building an industry within that country, because they're designed in one country and have previously been built in that same country, but now looking to build them closer to the operation. Now, the advantages of that, of course, is not only jobs, high skilled jobs, taxation revenue for the country that we're talking about, but also, much better for the environment, because you're not having to, bring parts from, into one country, then bring whole units from that one country into another country. you can, bring parts and componentry, etc., directly into the country that it's going to be used in. So, I think a win-win all up.
Michele, really appreciate your time in give us an insight to what is happening in the world of technology, obviously using robots and AI, and what the industry has to look forward to in the future. And especially recording this on a public holiday in Australia. So really appreciate your time. If our audience wants to reach out to you, if they've got any questions that they may want to ask you, how can they go about doing that? And social media platforms, ones that you're on.
So apologies for my dogs in the background.
Yeah, no, that's all right. That's fine.
The one challenge with COVID, everybody, is that my dog now knows when I say that word beginning with T and ending with U, that I'm finishing, and she'll get her ball thrown, and so she's learned to bark at that command now. So apologies, but look, so just reach out to me on LinkedIn. Either try to press the connect or send me a message, and I'll respond straight away. I'd love to speak to any of your podcast listeners much more about either what they're trying to do, what their company's trying to do, some challenges that they're facing, some concerns that they've got, or just any other question on mining technology and the universe as we know it.
Yeah, thank you for that. And those that are listening, I hope you enjoyed that episode, because obviously technology is coming increasingly more into our workplace and into our careers, and even socially as well. And there's certainly a lot of advantages of using technology, and it's just understanding them and I suppose having the confidence to try some of these technologies. So please reach out to Michele if you have any questions. And yeah, the audience appreciate if you can pass this podcast, make people aware in the industry of this episode, because I think it's important, and it's our future. So appreciate your continued listening. Appreciate your continued support as well. Please keep telling others about this podcast, others in the industry. I really appreciate your help. So until next time, happy mining.